Today we shall have an introduction to NoSQL databases, specifically MongoDB, and we shall cover the aspects which are relevant for using MongoDB from a developer standpoint. The agenda for today's discussion will be primarily around movement from SQL to NoSQL databases, introduction to MongoDB, a hands-on assignment, typically what we shall walk through, some discussion around design models, further discussions around language drivers, disaster recovery, and then a small overview on what MongoDB could do, specifically in the context of big data, which is becoming more and more relevant today. Moving from SQL to NoSQL. If you look at the history of how databases have evolved over the decades, we go back to the 1990s where you had relational databases fundamentally driven by CORDs, typically what we call relational database management systems, or RDBMS for short. We would then move to the early 2000s where you would have operational databases and databases, and data warehousing again became just about being seeded into modern day corporations around OLAP and data warehousing. Now, from 2000 to 2010, you actually had these further being split into RDBMS, NoSQL, MongoDB, which is going to be our prime subject for discussion today, and of course moving to Hadoop and OLAP and DW. So this is, in short, is how database technology has evolved over the decades. And SQL storage was primarily designed for storage, and when data transfer was costly, processing was slow, applications were oriented more towards data collection. And initial adopters were financial institutions. Back in the day, when firms started first moving on from mainframes on to individual desktops, you had databases which were built around SQL storage. And then, of course, data collection or transactional data entry was one of the most prime drivers for designing SQL databases. For some of you who are familiar with database technology, you would be familiar with concepts of CORD rules and so on and so forth. This was primarily the driver. And as we said, the large banks and financial institutions, mortgage houses, trading brokerage houses, and insurance firms were typically the early adopters for SQL databases. Features of SQL storage are usually it is structured in terms of logical units known as schema. There is this whole preoccupation with relational storage of data. You have primary keys which determine or which significantly identify information of a particular record. You have foreign keys which reference the primary key in additional tables, and then you have constraints which limit the values that certain columns or fields could hold in conjunction with the primary keys. The data that was captured in SQL storage was primarily transactional, and the yardsticks which fundamentally determined or regulated the sanctity of this data was around atomicity, consistency, isolation, and durability. High availability through robustness was another key requirement of this, where you had to minimize failures. Databases were optimized for writes, and they would typically scale up for huge amounts of transactional data, which would typically get pumped in from time to time into these databases. Now, we start with the concept: what is NoSQL storage? NoSQL storage is fundamentally different from SQL storage. It is designed for use cases where storage is cheap, data transfer is fast, and much more processing power is available. So here we're looking at a scenario which is obviously geared towards a much more specialized use case where transactional SQL storage is definitely not going to help us. Clustering of machines is also possible, where applications are oriented towards consumption of user-generated content and better on-screen user experiences and demand. One of the classical pitfalls of having SQL storage is that, especially when you have huge amounts of transactional data retrieval, especially when it comes to sifting through normalized data, where you have to go through a loop of 100 to 150 tables at a minimum to get to a particular data point that's relevant. That use case becomes really redundant when is looking at real life user generated content scenario. For instance, social networking data, or data mobile usage on data, or customer interaction text based semantics data, where possibly every word or every syllable uttered could possibly be a dimension or a primary key to determine all the other factors. So normalizing it further makes the whole premise very, very difficult to retrieve data. And so NoSQL storage is the perfect answer for such use cases. It's semi-structured, meaning there are no schemas. Note the biggest difference between SQL and NoSQL storage. You have the key mottos being consistency, availability, and partial tolerance. Now, there is a high availability through clustering. It presumes that you will have failures. It is optimized for reads. Note the primary constraint or the primary use case for using NoSQL storage, where we spoke that SQL storage fundamentally implies that you have normalized databases, and the whole premise behind designing a SQL database is consistency and regular and normalization of table structure. Typically, NoSQL storage scales out. Now, what are the different types of databases that you have? Okay, in SQL RDBMS you have MySQL, PostgreSQL, Oracle, etc. Stores data in tables having columns, basic number text data types. It's a strong query language, typically 4th generation language such as SQL. Transparent values. Query language can read and filter on them. A relationship between tables are based on values. Suited for user information and transactions. Okay. Typically, if you would have an Oracle database where you were trying to where you have a library management system, and you would have one table which typically is a book master, which typically would have a B for the book ISBN number or the library registration number for the book, and your ISBN number for the book. In turn, you could have it as a composite key along with your library ID, or you could have it as one of the attributes to this particular book, and then you would have further attributes such as book title, author, year of publication, publisher, and so on and so forth, about further qualified titles that you would wish to have in your library based on how you are sequentiating or arranging catalogs or titles in your library. Say, for instance, you would want to call it as fiction, science, whether it's a book or it's a periodical, and whether it's a duplicate copy, or whether you also have a soft copy available for download. Does it also have a CD along with the book, so on and so forth. You could have n number of additional fields. Now, this is the book master, and then you could have a transactional table which typically has the date, has the user ID, and it has the book ID. So transaction records when the book was issued, when the book is supposed to be returned, when is the actual return, and so on and so forth. Then you would have a third table which would tell you the user information, the users who sign up to the library, their user ID, primary name, secondary name, bank account number, address, so on and so forth. So your transaction table would reference two master tables, your book master as well as your user master. So this is typically how a SQL RDBMS, a very simple use case where one can explain a book master, library transaction system using an RDBMS.